Ever notice how some plastic products look clean and tight, while others feel like they never quite line up? Most people blame the machine, but the real answer usually starts way earlier, in the design phase. If you're inventing, launching, or scaling a product with plastic parts, injection molding is how most high-volume parts get made, from consumer gadgets to packaging. What a lot of teams miss is that your quality, cost, and reliability get decided long before the first part comes out of the tool. Here's the quick breakdown. Injection molding is basically you melt resin, inject it into a precision mold under pressure, cool it until it solidifies, then eject the part. That cycle can repeat in seconds for smaller parts, which is why it's so efficient at scale. But here's the catch. The mold design, every runner, gate, vent, ejector pin, and cooling line, sets the limits of what you can realistically make. And the choices you approve, material, wall thickness, draft angles, ribbing, and gate location, they all shape how that part will fill, cool, shrink, and release. If you get those details wrong, you'll fight problems like sink marks, warping, short shots, bad cosmetics, or parts that don't eject without getting chewed up. If you get them right, production gets smoother, parts look better, and quality becomes repeatable. At Rabbit Product Design, we've spent years helping inventors and founders navigate this. We've developed more than 2,000 products, with senior engineers averaging close to 3 decades of real-world experience. And what we've learned is simple. If you don't sweat the details in design and prototyping, you end up paying for it when you cut steel. Because once the mold is built, changes get expensive fast. That's why we start with the fundamentals. Is injection molding actually the right fit for your volume, cost targets, and part geometry? Then we dial in the design decisions: wall thickness, draft, gate strategy, ribs, bosses, and undercuts. And we validate the riskiest stuff with prototyping before we commit to tooling. If I were in your shoes, I wouldn't bet on production magically fixing design mistakes. If you keep skipping the details in phase 2, you can end up with parts that cost more, look worse, or just don't work the way you need. If you want help getting your design ready for real-world injection molding, click the link below to learn more. And if this was useful, subscribe, like, and ring the bell.